And welcome back, everyone. This is St. Raz, and welcome back to Cajun Coding, where we're going to be finishing up our String2 series of exercises on Mr. Palante's Codingbat website. And 3 more of these left. And we've got star out. Okay, so it says return a version of the given string where for every star in the string, the star and the characters immediately to its left and right are gone. So AB star CD yields AD. AB star star CD also yields A and D. So now we are going to be returning a string, as you can see there. The return type is string. So we're going to declare a string answer and initialize it as an empty string. And we're going to be returning answer. And then we're going to have some logic here in the middle. I have a for loop, as might be expected. And that's pretty standard boilerplate for loop there. Okay, now we're going to iterate through this string. Now strings have indices, arrays also have indices, and we can use for loops to iterate through there. You know, if I happen to call a string an array, that's incorrect technically. I think I might have done that on previous videos. You iterate through it using an integer to refer to a specific index of the string or of the array. So they behave very much the same way, but technically this is a string, so if I call it an array later, apologies in advance for that. Okay, let me see. So if I is, okay, actually if I is 0 and the character at that index is not equal to the asterisk, the star, we're going to add that character to our answer string that we're building. Okay. Now this isn't an else, this is another if. If I is greater than 0, oops, those are square brackets. We want the curly braces. And this is going to be much the same. I am having a hard time getting the right keys there. Alright. Okay, so what we've got here is if I is equal to 0 and the character at I is not a star, we're going to add that character to that character right here to our answer string. We're going to start off with that. Okay. Now, if it is a star, well, I'll get to that in a moment, but so we're going to copy that character. If it's not a star, we're not. If it is a star, then we're not going to copy the star. Now, on our second if statement here, I is greater than 0. Okay, so we're going to check the character at the index to make sure that it's not a star. And then we're also going to check the character to the left. And we know that there's a character to the left because we know that I is greater than 0, meaning that it's not the very first character of that string. Okay, and if this all resolves to true, we're going to copy that character. And now the last if that we need here, if I is greater than 0 and string character at I is equal to star and the character at I minus 1, and you know what, I made a mistake up here. This is I minus 1. The character to the left is I minus 1. Okay, character I minus 1 is not the star. We're going to reassign the value of answer to answer substring. And it's going to be, what we're basically going to be doing is we found a star, so we're not going to add that star, but what's more, we're going to subtract the last character that we wrote, because we found a star, so we're going to remove the character to the left. And what we're going to do is it's going to be substring 0 and then answer dot length minus 1, and that's going to delete that character there. And let me see, is that going to work? Yeah, that's it. And as it turns out, because of the logic here, it's going to iterate through each index in the string, not array, and this logic will handle that. That should be it for this one. Let's go on to the next one. Star out plus out. Given a string and a non-empty word string, return a version of the original string where all characters have been replaced by pluses except for appearances of the word string which are preserved unchanged. Okay, so we are going to be returning a string. Well, it does say return a version of the original string. I don't think you have to, though. I think we can return another string. Let's see what we can do here. Yeah, I'm pretty sure we can. Now, sometimes the statements can get really long where we're calling different strings or different variables and such, and then calling methods on them and everything. So we're going to make things a little simpler for us here. We're going to put int, and we're going to use slen for the str length, and we're going to use wlen for word length. We're going to be using those values a little bit, so this is going to make things a little bit easier in terms of typing, but it's also going to make it a lot easier to read. So let me see, and we're going to be returning the answer string, and we're going to use a for loop here. Let me see, I less than okay, so when we find the word, we just print the word. Everything else is going to be pluses. So let me see, if I is less than minus, okay, we're going to be taking bytes out of this larger string the size of the word. So if we get towards the very end of the string such that we don't have characters left as long as the word, string, then this logic is not going to hold. So we're going to check for that. We're going to make sure we have that many characters left. Okay, and otherwise, if we don't have enough characters left to match the word string, then we're just going to, everything left is going to be the little pluses there. So we're going to add those to the last few characters there. Now while we're still in here, we still have space. We're grabbing those word sized chunks of our str string. So, and those may or may not match. If we don't have enough characters, obviously they can't match. But if we do have enough characters, they may or may not match. So we're going to have another if statement in here. If, let me see, actually what we can do is we're going to create another string, and we'll call it temp, because it's not going to be here very long. It's just temp, and we're going to make it str substring, and the substring is going to be from I to I plus word length. And if temp equals word, we're going to add the word answer to the answer that we're building. And we're also going to iterate this I by word length. Now, each iteration, each execution of the for loop is going to increment it by 1 already. So it's going to be wlen minus 1, because the for loop is going to iterate it by 1. So, and then otherwise, if it doesn't match, then we're going to append to answer that plus character. Okay, and I think that's going to do it. Might have, oops, what was this? Line 8. Why do I have that brace there? Okay. Okay, I'm not sure about this curly brace here. If, is that it? Else without if. Alright. No, this else should be should be from this if here. Okay, so it's mostly correct. Here we go. Oh, let me see. And it's those very last ones. And I think it should be less than or equal to. There we go. Okay. So you can see here we've got the for loop, which is pretty self-explanatory. We have the if, and if this is going to be, we're looking at word sized bytes of str, and this is just checking to make sure that we have that many characters left based on where we are in that for loop. If we don't, this if goes all the way down to this else, and we're going to be replacing all our remaining characters with the plus sign. And now if it passes, then we create this temporary string. We check to see if it matches word. If it does, we write word and then iterate forward a little bit so we're not copying too many characters, basically. Okay, and if it doesn't match, then we put the plus signs there as well. So And I think we've got one more. And this is word ends. Given a string and a non-empty word string, return a string made of each character just before and just after every appearance of the word in the string. Ignore cases where there's no character before or after the word, and a character may be included twice if it is between two words. So you can see what they're talking about here. We've got XY, we've got a C before and a 1 after, C1, and then another appearance of XY with 3 and I afterwards, C1, 3I. And this one we've got XY on the end, so it only has 1. And of course we got another one on the other end, so it only has 3. And in this case we've got 2 appearances of XY. We only have the one character, but it's after one and before another, so it is doubly represented there. And that's as intended for this particular exercise. So, alright, so let's go. Now we are returning a string, so let's go ahead and set up our string answer, and we'll go ahead and set that up as an empty string. Now we've got, I see the str and the word strings, and we're going to need to use the length of those, pardon me, in a few places. So let's go ahead and make it easy for ourselves and use slen for str length and wlen for word length. Okay, and we're going to be returning the answer string, and then most of our logic is going to be inside a for loop. Okay, so this one's going to be I is less than, I think that's going to be CS length minus the word length, and that would be a little too short, so I think it's +1. Okay, and then we iterate through there. Okay, and inside this for loop, okay, so if in the instance that we're at the very beginning of the string, so if I equals 0 and, actually let's go ahead and use a temporary string here, temp equals, and we're going to set that up as str substring I plus word length. Okay, so if I equals 0 and temp equals word, oops. Okay, so if that's the case, then we're going to want that character right afterwards. So we're going to append that to our answer string. Let me see, I plus word length, I plus word length plus 1. Okay, and if we're elsewhere in the string, that would be I is less than the string length minus the word length, oops, and temp equals word, then we'll append to answer substring. Actually, this should be greater than 0. Actually, no, this would be I is... Actually, I kind of get these mixed up. That's okay. I mean, I'll get this to work. So, if I is greater than 0, this is going to be the character in front of it. So it would be str substring. It would be I minus 1, and then I. Okay. And now this one is anytime I is less than basically the end of the string here, where the word is representing the very end of the string. Answer would be plus equals the substring, and this is the one I had up here incorrectly. So if you have a substring, it would be I plus word length, and then ending I plus word length plus 1. And I think that should do it. Yes, there we go. Yeah, actually I had these backwards before. So we've got, so what we've got here, just to break down the logic a little bit, we've got our for loop. This is going to send us one by one through this string. Okay. We've got our temporary string, which is just going to make us, it's just going to allow us to save a little time. Otherwise, what we have here is temp equals. What we'd have to put here is going to be string substring I plus word length. Okay, and this actually I can, well, I think it should run. Yeah, run. Let me see, and let me show you how this one temp. Rather than temp, we're going to take this out and put substring. Let me see, I plus word length, and we can comment this out, and it still runs. See, so we're not using temp anymore, but using temp saves us a little bit of typing, but quite a bit of, it provides quite a bit of clarity there. Okay, and we want to encourage readability. Remember that a compiled program is can be very compact, and most people would not be able to read machine language at all. A lot of what we program is for human eyes, not for a compiler's logic. So you want the code to be readable as much as possible. Now we've got a few minutes here. We've got to the end of a string here. I want to show you guys how you should cheat. Oops, what did I do? Did I not finish it? Back this out all the way? There we go. Is that going to run? Yeah, it runs. I think I didn't finish it out already. I want to show you guys how you should cheat. And that sounds weird, but remember that remember your objective. The objective when you're performing exercises and such like this is to learn. When you're writing code in a professional environment, if you steal proprietary code, that's not good. You're not supposed to do that. In a professional environment, the idea is to come up with a solution for what you're doing, and sometimes that involves open source solutions or legacy code or something like that. Sometimes it's a brand new solution. A lot of times you're going to be writing it yourself, but your objective when you're performing exercises like this is to learn. So at the end of the day, if you hammer it out and you can figure it out yourself, that's great. But at the end of the day, if you have to look up a solution, that's not a failure. But you've got to, you might want to call that cheating, quote unquote cheating. But you still succeeded if you look up that solution and you've learned. At the end of the day, if you still know and understand how to write that code yourself just as effectively as that person who is, banging their head against a wall until they figured it out themselves without looking up an answer, then it's, equivalently your success is just as great as theirs is. But I'd like to share with you, what works for me, the right way to cheat, so to speak, so that you can facilitate your own learning in a way. So let's say we get stuck on this. We can't get through the logic. We're not, maybe we're off on a tangent or trying an approach that's just not effective. So let's go and do Codingbat solutions. What is this? Word end. And we find one. Okay. And here it is. Here's the solution. And oops, they've got, let me see. There we go. That way we won't have the numbers. Okay, let's go ahead and plug it in. Let's see how it works. Alright, there we go. Look at that. Works. Now we go on to the next problem, right? No, of course not. If you get stuck and you can't get anywhere, you need to figure out how it works. If you have to look up a solution, if you have to come to my channel or whatever, that's fine. It's absolutely fine that you do that, as long as you follow up. You got to cheat the right way. And cheating the right way means you look at the code, really look at it, and figure out what it is that they're doing. Okay? Now here we've got this short, the little integer for holding the length of the strings there to simplify the code down here. Okay, that's pretty obvious what they're doing with that. They've got string fin. Where's that code at? Okay, well, it's probably short for final. I was kind of wondering because fin that's the French word for end, the end. You'll see it at the end of like French films and stuff. They'll have fin at the very end. I was kind of wondering if that was a source of somebody who was French or whatever, but it's probably just short for the English word final, as in the final solution there. So, but in any case, yeah, so that's going to be their returning string for the solution, and then you step through it. And this is what you should do. You should annotate the code. So what we've got here is, what you can do is put this up here. Variables for solution and string lengths. Okay? Now there's two slashes here, and you'll see in this IDE it turns the text green. That's invisible to the compiler. The compiler doesn't see it. Okay? But it's useful there for making notes. Okay? For loop. And you might want to add another note here. Watch for termination of loop, because it's not so simple as I is less than the length of something. What we've got is the string length minus the word length, because we don't want our word check to overrun the end of the string, and then plus 1. And then inside here you might put a note here. Temporary string for comparison. And then here we've got if check for if check for word match. Okay. Now what you should do is you go through his code as you go step by step. You should understand every line of code there. Okay, and if you look through it and step through it in your mind, find it. But go ahead and take notes too. And when you take those notes, understand why it's doing that. Okay, and then what you do is you take the actual code that's executed by the compiler and delete it. Go through there and just delete all the code. But what you're doing is you're leaving your comments. You're leaving the comments. So then what happens is you go back and you write the program using those comments. Not using Control-Z, you know, like the way I am there. But what you do is you go through and you write you write the code according to the comments, and of course the position of the comments is going to give you, a very strong clue as to where things are in the code, how they're laid out, the logical, the process of executing each element in the logic of the solution. Is that as good as being able to come up with it your own? No, but it might be a useful intermediary step. Have to crawl before you walk, have to walk before you run. And if that helps, then do it that way. And another thing is, when you're done with the exercises here, don't be afraid to look back. What you do, and they actually have a forget it here, and it forgets the solution. Okay, forgets the solution, and then what do? You go back and you write the solution again, start all over again. If you can go through and do the solution, and of course you see I make little mistakes all the time, missing semicolon or misplaced brace or something like that. That's no big deal. If you write through the solution and there's something like that and you see where it is, you fix it, fine. You may not need to go back. But if you go back to a previously solved exercise and you're having trouble with it, go ahead and work through it again and then go on. And I encourage folks to go on through the exercises. Like if you do this one and you fix it again, then go through to plus out. And when you solve that, go through to word ends, And if you get stuck and you have to go back and look up a solution, then go ahead and work through it. But then go on to another one, work on it, go on through another one, work on it, and then go back to the one you needed help with until you can solve it, by yourself. When you can solve it by yourself without any substantive errors, I mean, there's little things like a parentheses or something, which you can fix, when you see when the compiler yells at you and the debugger complains. That's no big deal. But, don't give up on an exercise. Once you find the solution, work through it, understand the solution, and then you should be able to work, to solve it, not from memory, but from the understanding that you've built up, if not through your own work, through studying the work and solutions of others, until you really achieve understanding. But I think we're going to go on to array 2. Rather than go to string 3 while we still just finished with array 1. So we'll go ahead and do array 2 and then string 3 and then array 3. A functional, like using lambdas and maps and recursion, I think we'll go ahead and do arrays and then strings before we go on to those. But thanks so much for tuning in, guys. Appreciate you. As always, like, comment, subscribe. Any requests or questions, I'd be glad to read them. Y'all have a great night. Bye-bye.